All right, guys, welcome back. We're going to do another example here with the two, uh, I'm sorry, when we compare the means. Okay, so let's go ahead and let me get a different color here. I'm kind of getting sick of red. So let's talk about our hypothesis, our null, and our alternative. Okay, so if we read the problem, it says a survey indicates that the mean annual wages for forensic science technicians working for local and state governments are $53,300 and $51,910 respectively. All right, and that means that this number, of course, is, oh, where'd my pen go? It's kind of hard to do this without a pen. There we go. All it's saying is that this number is the local number and this number is the state number. So it's kind of talking about them in order. Okay. And the survey includes a randomly selected sample size of 100 from each government branch. All right, so they surveyed 100 people about this, and the sample standard deviations are 6,200 for the local and 5,575 for the state. The two samples are independent. At a level of significance of 10%, is there enough evidence to conclude that there is a difference in the mean annual wages? Okay, so once again, what are we trying to claim? Well, we conducted the survey, right? And we found that the wages are different. Okay? Obviously, and I say obviously tongue in cheek here, we would assume that the mean for all forensic science technicians would be about the same whether they work for the local or the state government. The claim is that they are not, which is our alternate. Okay? Now our alpha value is at 0.1. And if we were going to go look this up on our table, right, we would use our two-tailed test again. Because remember, since this is not equal to, it can either go a little off or in the rejection region to the right or to the left. So two-tailed test. And when we find our values on our table, we should get negative 1.645. And for the positive value, it should be exactly the same, just with a positive sign. All right, so if I'm drawing or sketching what's going on, we should get something that looks similar to this. And of course, this is negative 0.645. Looks great. And that looks fantastic as well. Okay, so now we're going to hop over, and I'm sorry I can't get my, oh, there it is, finally. All right, so let's erase this guy. Oh, good, looks much better. Sorry about that. I kept on trying to press it multiple times, and it just would not respond. So let's go over here, and let's calculate our standard deviation statistic that we need. And remember, that's x bar sub 1 minus x bar sub 2. Once again, I'm going to write the formula out. I would suggest you do that multiple times so it starts to become ingrained in your memory. All right, and now let's go ahead and plug in some of the values. What's the standard deviation for the first category, the local government category? Well, the standard deviation was 6,200. And I'm going to square that. Now, what were the numbers of people that they surveyed, or what was the sample size? Of course, we would say 100. All right. The standard deviation for the state government is 5575, and we are going to square that. Also divided by 100 because that's how many people they surveyed. Go ahead and simplify. You should get a number that's approximately equal to $833.79. Okay, give or take. Now, let's go ahead and calculate our z statistic to see whether or not this rejects or fails to reject. So I'm going to have my average for the sample, right? X bar 1 minus X bar sub 2 all minus mu sub 1 minus mu sub 2, all divided by our standard deviation statistic. Okay, there's our formula. Let's go ahead and plug in. All right, x bar sub 1 is 53,300 minus 51,900. And of course, mu1 minus mu2 gives me 0. Remember, because of the null hypothesis, we are assuming them to be equal. So a number minus itself gives me 0. And I'm going to use my 833.79 from above. Go ahead and plug that into your calculation device. You should get approximately 1.667. Now, 1.667, and let me go ahead and switch colors here, because this will definitely fall right here, and that is in the rejection region. All right, so we reject our null hypothesis. And if you were to write a sentence about that, you would say, therefore, there is enough evidence at the 10% level of significance to support the claim that there is a difference in the mean annual wages for forensic science technicians working for local and state governments. Okay? Hope that example helped, guys. Keep chugging away, working at these problems, chipping away slowly, one problem at a time, and you will be more successful than you guys probably even realize. Okay? Keep up the good work, and I will see you soon.